We're now going to do an example of elimination with 3 variables and 3 equations. This may seem a little intense at first because it's a longer process, but it's a lot the same thinking that goes into 2 equations and 2 variables. And so what happens is we're first given a system of equations. So for example, say we're given this system. 3x plus 2y plus 7z equals 8, x minus y plus 2z equals 1, and negative 3x minus 4y plus 9z equals negative 10. So the first thing to do is to pick one variable we're going to eliminate. There's actually not a right answer here. The thing I would note is your goal is just like with 2 variables and 2 equations, that you want to pick something that you can create the same number in positive and negative format, so when you add them together they disappear. So just the fact that there's already a 3 and negative 3, it would already disappear in 2 sets of the equations. I'm going to pick x. You would end up at a solution picking any of them. It might just take a little bit more creative timesing of numbers to get them to eliminate. So first, taking the bottom 2 equations, I'm going to number these 1, 2, and 3. So we know what equation we're referring to. So let's say I take equation 2 and 3. So I have 3x plus 2y plus 7z equals 8, and negative 3x minus 4y plus 9z equals negative 10. If I add them together, that cancels. Negative 2y plus 16z equals 18. There's an equation now with 2 variables. Well, now I'm going to pick 2 different equations that aren't 2 and 3, but it could be 1 and 3, it could be 1 and 2, just not 2 and 3 again. So I'm going to pick 1 and 3 because if I multiply this top equation by 3, I'll have a positive 3 and a negative 3 to once again cancel. So 1 and 3 are going to be my next 2 I pick. So 1, if I multiply equation 1 by 3, I get 3x minus 3y plus 6z equals 3, and my second equation stays the same in this case. Add them together, that cancels. Negative 7y plus 15z equals negative 13. Oh, excuse me, this should have been a negative 10, so this should be a negative 2. Good thing is sometimes to check yourself, because it's very easy to miss one part of this, which could then throw off later. See, once again, miss the negative 10. So negative 7. Okay, so now that we got both of those fixed with the negatives, we now have 2 equations with 2 variables. So I'm going to rewrite both equations we came to down here. We had negative 2y plus 16z equals negative 2, and negative 7y plus 15z equals negative 7. So once again, I get to pick one of the variables and try to eliminate. In this case, I'm going to eliminate y. And so 14 is a number they both go into. I'm going to make this top equation become the positive 14 by multiplying by negative 7. And this one become the negative 14 by multiplying by 2. So my new equations become 14y minus 112z equals 14. And my bottom equation becomes negative 14y plus 30z equals negative 14. These cancel. This part becomes negative 82z. And this is equal to 0. So z equals 0. Substituting z back into either one of these equations is going to give us y. So I'm going to pick the top one. 16 times 0 equals negative 2. Negative 2y plus 0, so that goes away, equals negative 2. So y equals 1. Now taking both of these and substituting them back into one of the originals, will give us x. So I'm going to pick the top one. So I'm going to rewrite it down here of x minus y plus 2z equals 1. That was the original equation. So we don't know x. We know that y is 1, so minus 1 plus 2 times 0 for z equals 1. X minus 1 plus 0 equals 1. Add 1. X equals 2. So the point 2, 1, 0 is where these three equations would cross in a third dimension. The same process applies if we're doing any system of equations with three variables and three unknowns. So eliminate one of the variables, making twice, so you get two equations. Eliminate one variable, back substitute, take both, back substitute, and you'll have your answer.